Whether it's donuts, french fries, chicken, or Oreos, fried food is everywhere, and it's delicious. I mean, isn't that why we all go to fairs? Besides making our taste buds happy, deep-fried foods also involve some really cool chemistry, from the cooking process itself to the kind of oil and batter you're using. When you submerge a piece of food into really hot oil, a bunch of chemical reactions start happening, cooking your food and giving it that crisp outer layer. Typically, you'll want the temperature of the oil to be around 180 degrees Celsius, but that varies depending on the recipe. You'll know the oil is hot enough when you drop some food in and it starts bubbling. Now, some people might think that that's the oil boiling, but it's not. It's actually moisture boiling off the surface of the food, since the oil's temperature is nearly twice the boiling point of water. As the water leaves the food, two things are happening. First, the food's surface dehydrates and a crispy crust begins to form. But also, the escaping water molecules leave gaps that let oil molecules enter the food, which is what researchers call the oil uptake. In fact, some studies have shown that the amount of oil uptake is directly proportional to the amount of water that's lost. More oil increases the food's fat content, and therefore its energy content, also known as the calories. And if too much oil gets absorbed, you might be left with a greasy mess of a meal. But you don't want to take your food out of the oil too soon either. Otherwise, the outside won't be hot enough for long enough to cook it all the way through. That's because cooking is all about heat transfer. When food is in a deep fryer, the outside layer of molecules is heated up thanks to convection, from the currents of hot oil flowing around. Then all of those food molecules start bumping into each other and transferring heat energy. So the inside is heated because of conduction. So those are the basics of deep frying food. But there's a lot more that goes into making a tasty corn dog. Like, what happens when you add batter or a breading to the outside of your soon-to-be fried food? Well, batter is basically an extra layer between the food and the hot oil. So the batter is mostly what's getting dehydrated. All that heat transfer is still happening, only this way, the food at the center holds on to more moisture and doesn't get too dry. As fish and chips, fried chicken, and tempura lovers will know, a little batter can also let you add more flavor to the food and give it a crunchy, textured crust. You can even add beer to your batter to make the crust softer and crispier. That's because the carbon dioxide in beer forms bubbles that fluff up the batter, and foaming agents, which are certain proteins found in beer, keep those bubbles from bursting as fast as they normally would. Plus, the ethanol in beer evaporates faster than water, because alcohol molecules aren't as strongly attracted to each other as water molecules are. This means the batter will dry out faster, so the food doesn't have to be in the fryer as long to get a crispy crust. But one study did show that beer batters do have more oil uptake than water-based rice or wheat batters, so calorie counters be warned. You might also have heard that some oils are better to use than others when frying food. Different oils are made up of different kinds of fat molecules, or lipids, and have different nutritional benefits. They can also affect the flavor of your food because they break down differently. See, every oil has something called a smoke point, a temperature where it starts to create smoke, which can give the food a bad taste. Basically, the heat causes the lipids in the oil to break down and produce some volatile compounds, which are chemicals that easily can become gases. Some of these leave the oil and enter the nearby atmosphere as smoke, but others can enter the food and change its flavor. Corn oil, for example, is made up of lipids with lots of double bonds, also known as polyunsaturated fats, and it tends to break down more easily at lower temperatures. That's because polyunsaturated fats have some weak carbon-hydrogen bonds, which break and set off a chain of chemical reactions that eventually produce volatile compounds. So when you're deep frying something, you'll probably want to look for an oil that has a high smoke point, and most vegetable oils fit that bill. Deep frying food is a lot more scientific than you'd expect. You have to apply all kinds of knowledge about heat transfer and fat content so that your food is actually edible. So treat this as some food for thought the next time you're eating some delicious hot French fries. Thanks for watching this episode of SciShow. So Thanksgiving is coming up, along with a bunch of other holidays. And we've got just the thing. If you want to look really snazzy in the kitchen, or for any messy task, head over to dftba.com/scishow to check out these awesome new SciShow aprons. And as always, go to youtube.com/scishow and subscribe. The process of losing the alcohol depends on a few factors, so you can't assume that it'll all be gone by the time the dish is done cooking. It makes a lot of sense that alcohol would evaporate out of food